Hello, geometry. Welcome to lesson 10.2 on lines tangent to a circle. So I know we used the idea of tangent when we talked about trigonometry, but I'm pretty sure these two ideas are not related because tangent in the trigonometry sense is a ratio. Tangent here is going to be a line or a segment involving a circle, okay? But a very important type of segment. All right, so understand tangent to circle. What is the relationship between a circle and a tangent to the circle? So a tangent to a circle is a line, could be a segment, a line, that intersects the circle at exactly one point. That point is then called the point of tangent C. So if we take a look at this picture below, sorry about that. I'm trying to drag this out of the way so we can see. Yep. Okay, so if you take a look at this circle below, the circle C has tangent line M with point of tangency X. So this is going to be, this is going to be your line or your tangent line, and point X is going to be your point of tangency. So now I'm going to use this tool. Let me clear these markings, and let's use this tool in Desmos to see, do some investigative work. So if you take a look here, it says use the tool below to move points X and Y. So if I move point X, notice my circle shrinks, right? I'm controlling my radius size. And now as I move Y, right, again, notice that it remains on that tangent line. Nothing changes. But as I move X, the point of tangency, notice that that tangent line does move. Okay, so really I think it's X that is really in control there. All right, so let's go back to our notes here, and let's try to prove this idea. The proof is not, in my opinion, very sophisticated. It's more of a clever proof. Okay, so here it is. It says, so what is the relationship, right? So notice that CY, so CY is this, this extended segment that goes from the center of the circle out to the tangent line. Notice that CY is made up of CZ plus ZY, right? Okay, so CZ is a radius, right? So CZ is a radius, and notice that there's also CX that's a radius, right? So we know that all of the radii of a circle are equal in length, right? So if CY equals CZ plus ZY, then CY also equals CX plus ZY, right? Just pretty much a basic substitution. We took out CZ and put CX in its place. Well, it's easy to see that based off this picture, CX is less than CY. Okay? So if CX is less than CY, then that means that C to X is the shortest segment. The shortest segment from C to the tangent line. Well, you learned way back when that if I'm looking for the shortest segment between a point and a line, the shortest segment between a point and a line is perpendicular to that line. So therefore, the result of this talk is that the tangent line is going to be perpendicular to CX. Your tangent line, this tangent line, I'll let it T, is going to be perpendicular to your radius CX. And this is a main idea, because if they're perpendicular, then what I just marked is a right angle, and this is a right triangle, and we can do a lot of cool things with right triangles. So let's formally introduce this idea. It's just called Theorem 10.1 in the converse. If AB is tangent to the circle at P, then AB is perpendicular to CP. And of course, you have a right angle right there. Same thing here. If you have a line outside the circle, right, perpendicular to a radius, then that line is going to be a tangent line. Okay. So again, a pretty neat idea involving tangents that we should try to remember. All right, so again, this is to talk about the tangent and how it interacts with the radius. So we're going to go here. So it says drag point A and the point on the radius, CP. AB is tangent to circle C when the blue chord disappears, right? So if I drag A and the point on here, right? And let's drag A. Right. And that blue line disappears, right? So it's blue, 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 chord, 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 and now we're tangent. There's your right angle. Okay? And again, anywhere else, it's not going to make a right angle, right? And again, until I make that perpendicular, we're close to, right? And there we go. All right, so let's use this idea in some problems. 3 to be exact. All right, so question, example 2 here, the first question. It says, is segment KJ tangent to circle P at J? So the real question is angle J a right angle? That's going to be a question mark. Is angle J a right angle? Do we know this or not? So in order to show this, we're going to use Pythagorean Theorem, right? Because if there's a right angle, then it'll be a right triangle. So remember Pythagorean Theorem, our good old friend, a squared plus b squared equals c squared. So in this picture, the 4 and the 6 would have to be c. That's 10, right? Add them. That would have to be c. I'll let 6 be a and 9 be b. So does 6 squared plus 9 squared, does it equal 10 squared? That's our question. Well, I type in 6 squared plus 9 squared, I get 117. I type in 10 squared, which is 100. They are not equal. So because they're not equal, J cannot be a right angle, and that means that KJ is not tangent. Okay. So that would be using the converse to prove if something is tangent. Next question. All right, part B. So now it's saying that segment ST is tangent. What is the radius of R? So we're looking for what X is, right? If ST is tangent, that means that angle S is a right angle. And we can now use Pythagorean Theorem again to find X. Now this time, right, this length, X plus 18. This is my hypotenuse, C. And then I'll let X be A and STBB. So again, we're using Pythagorean Theorem, A squared plus B squared equals C squared. I'm going to do X squared plus 24 squared equals X plus 18 squared. Okay, so first of all, this X plus 18 squared, there is a formula that I've been using in Algebra 1 that I've emphasized, but I will not do that. I'll just say write X plus 18 twice. And we're going to multiply it out. You might use the box method. You might use the rainbow method. I'm going to use the rainbow method. X times X times 18. X times X is X squared. X times 18 is 18X. And then the 18, the rainbow method, 18 times X is 18X. 18 times 18 is positive 324. Combine your 18 X's and you get X plus 36X plus 324. Bring down your X squared, and then we're going to actually square 24, and I believe that's 576, right? So X squared plus 576 equals X squared plus 36X plus 324. Now, this is a quadratic. So what you really should do is you should focus on getting everything to one side and making one side 0. However, if you have a 1x squared over here on the left-hand side and a 1x squared over here, when you look to combine them, you're going to subtract, and they're going to cancel. And now this is no longer quadratic. This is a simple two-step linear equation. 576 equals 36x plus 324. We're going to subtract 324 on both sides to get 252 equals 36x, and we're going to divide by 36. And lucky for us, this is a nice even number of 7. So our radius is 7. And last but not least, C. So now it says line M is tangent to circle T at B, and line N is tangent to circle T at C. What is the value of X? So now we're looking for this missing angle. Okay? So we need to remember that when a tangent line intersects the circle and meets that radius, that it creates a right angle here, and same thing down here. We have two right angles. And if we look at this quadrilateral A, B, T, C, we know 3 of the 4 angles. We should be able to find the 4th angle using the Polygon angle sum theorem, n minus 2, or 180 times n minus 2. This has 4 sides, so n equals 4, so 180 times 4 minus 2, 180 times 2, that's 360. We should know that the 3 angles of it, or the 4 angles of a quadrilateral after 360. So we can say x plus 90 for one of the right angles, plus 135 plus 90 for the other one, equals 360. Add up what you know, that's going to be 315, not equals. X plus 315, and that equals 360. And we're going to subtract 315 on both sides. And x equals 45. And that would be degrees. Now, as a shortcut, right, in this picture, if you know that these two are 90 and 90, right, that's 180, which means that there is 180 degrees left between those two angles. So these two angles are going to be supplementary. So you can do the shortcut there too. It's up to you. All right, very good. Video 1 is done. Video 2 is coming up right next.